All right. Hola, hola, hola. How's everyone doing? Thanks. First of all, I can't believe it's been a whole year since the last great React Alicante a year ago, 2023. Who here in the audience is actually from Alicante? Okay, maybe give yourselves a round of applause. Alicante is awesome, right? Woo! I mean, who doesn't love Alicante? Alicante has everything. You've got the sun, you've got the sand, you've got beaches. It's like paradise here. I mean, oh, wait a minute, hold on, sorry, but that's not Alicante, that's Malaga, sorry about that. Okay, so, no, the thing is that like since last year, I had to shelter in place down south to avoid the cold winter months. The weather was like perfect and I was nearly blinded by the sun. So I was down in Malaga the whole time. But come springtime, I found myself waking up every morning to the sights and sounds of these marvelous birds swarming around. I don't hear sounds, not sure if they're sounds. But they were very nice birds. There we go, okay. And they got me curious about whether or not there might be algorithms that are inspired by nature. So that's when I stumbled upon genetic algorithms. And now these are not new at all. They've been around for many decades, and they're actually part of a larger field called evolutionary computation. That's loud. And that's actually a branch of artificial intelligence, which of course is very popular. So I was intrigued and I wanted to learn more about that. So we're going to call these genetic algorithms GAs from now on. And GAs, at a very high level, enable us to seek solutions quickly to problems in an iterative way using a population of individuals. Kind of a little bit like these Boyds up here, okay? All right, so who am I? My name is Kevin MAES, and I'm a web developer from the United States who's currently living in Spain. Yes! And over my career, I've done a whole combination of product development and project management and people management and working for startups and web consulting. And you know, I also do a lot of creative coding projects on the side in my spare time, which I love. But for the past couple of years, I've been lucky enough to work with the awesome team at Stately, building visual design tools, you know, basically for teams and people like yours, based on an open source state machine library called XState, which I know you've heard of by now. So, okay, so back to Malaga. Very similar to Alicante, of course, and also all the other great Spanish coastal towns. But there is one particular gem that I've discovered in Malaga, and I wanted to share that with you today. See what you thought. I know you want to get up and dance, I know. Okay, so who thinks that looks cool? Right, that looks cool, okay, right? I mean, if there were one word that I would use to describe that, it would be awesome. Totally awesome. All right. Now, did you all catch there was an Atari 2600 in that? You know, I don't know if you know what those look like, but that was actually, believe it or not, it was the very first game console that I ever played on. And that was back in the year 1980. Oh, is this microphone working? Sorry, static there. But it was the summer of that specific year that I found myself playing a lot of Atari, and I would play this game called Kaboom. I'm not going to ask if you know what that looks like. I'll just show you a video of what Kaboom looked like. Okay, cool. So that's Kaboom. So inspired by Kaboom, I decided, I wanted to try to build a game as well. And I also thought maybe it'd be cool if I tried to weave in a genetic algorithm into that game. So, of course, instead of one bomber, it's a genetic algorithm, I knew that I would need to have like sort of a population of bombers, many bombers, and also something that would be a worthy adversary that would evolve over time to be super threatening, maybe like the Terminator does. Or perhaps it would be, something crazy from the skies that's threatening, like the direct descendant of the dinosaurs. So I gave it some thought, and this is what I came up with. Wait, what? You're like laughing? That doesn't look threatening to you? Well, I should warn you, never judge a book by its cover. Yes. Okay, moving on. So my game is called Egg Drop, just like the Chinese soup, egg drop soup. Do we all know what that is? Okay, egg drop soup, it's basically a delicious soup. You drop an egg in it, you stir it around, it breaks apart. It doesn't matter, it's just a little demo. And the concept of the game is simple. There's going to be a chef, okay, moving around with a pot, and there's going to be a bunch of hens up there laying eggs, and the chef is going to try to catch them. And of course, the hen hopes that he doesn't catch them. Those are the little babies, right? Okay, simple enough. Let's get cooking. So, I built this game using React, React.js, React Conference. Now, normally, with creative coding, I like to use things like Canvas or P5.js. But in this case, I was really curious to try Canva. And Canva is known for its really great combination of React and Canvas together. It's also free and open source. So, by the way, I just want to say any of the code that I show in this presentation, it's all online. There's going to be a QR code and a link. You can catch it later, so don't worry about missing any code specifics. Okay, now Canva in React is actually pretty intuitive, and it's easy to get started, right? Your overall app has a stage component, and you can have one or more layer components nested within that, and each layer actually will produce a new canvas element on the page for you. And it uses the normal React Props API to easily attach things like event listeners and add interactivity, which is one of its main selling points. Now, layers can also help you with organization and also better performance by separating things like static layers from interactive layers. Okay. Another useful component is the group component, which can help you with relatively positioning the like elements that need to move together in a group. So here you can see other Canva components like rectangle or image, and they're all in a group. And we'll see a lot more Canva features soon. Okay, so after getting a Hello World project set up, I thought about the various game mechanics. So for example, who are my characters and how will they move? Okay, and who is going to be interacting with whom on the screen? Also, how does the player interact with the game? So based on all of these, I set out to create a series of POCs, or proofs of concept. Okay, so in this first video, we just see a single hen, and she's just moving back and forth on the screen in very linear motion. Okay, so far so good. But then in the second one, she's joined by all her girlfriends, and they're moving back and forth, but they each have their own defined range of motion. Now, we can effectively spawn any number of hens for our game. Now, a little hard to see here, but whenever the hens stop moving, then they get the urge to lay an egg. Now, not only did we spawn some hens, but we've also been able to allow the hens to spawn many eggs. Now, for this type of linear motion, we can use something called a Canva tween. And the word tween just comes from the phrase in between, which represents a series of intermediate frames between two known keyframes. And that gives the appearance of smooth motion. We instantiate a Canva tween here, and we assign it a node. And in this case, the node is like a React ref to an image or some shape. We give it a duration, and then we also give it a target position. Okay. Now, the single hen can now lay an egg, and eggs, when they hit the ground, can either transform into something else, or they can just land flat on the ground. I'm going to hydrate. You can hold your applause. Thank you. Hydration's important. Okay. So, Now the eggs basically land and they hatch into chicks. And then they run off the stage in either one direction or another direction. Okay. Okay, so now we have an abstract chef shape, right? Now the player can move the chef from side to side by pressing the left or the right arrow keys. The chef has a speed limit and also some very light acceleration and deceleration. Okay, our chef here gains a new power, and that is the ability to catch eggs, right? So the chef now has what it takes to play and maybe win this game. Okay, the chef has to catch the egg in a pot. Now that pot is smaller than he is, and it moves relative to him, thanks to that group component, and he can catch as many eggs as possible. Okay, catching eggs involves a form of hit detection between the chef's pot and one or more eggs. Now, in Canva and in Canvas in general, there are several forms of hit detection. Here they are. But in this game, we're actually very lucky because we really only need a very limited version of the bounding box detection. So for example, if the egg's bounding box intersects with the chef's pot rim box, then it's a hit. And we can also ignore a lot of the detection cases for better performance. For example, when the eggs have not gone far enough down to reach the chef, or when they're not even on top of the shelf in the first place. Okay. Now, in this one, the eggs are a little bit more egg-shaped. They also rotate as they fall for a more realistic falling experience. And to get that egg shape, these eggs are now imported transparent PNGs. Let's talk about state machines. Okay, yes, let's applaud for talking about state machines. Thank you. Now, state machines are a way of modeling your software such that your application exists in one or more states, and you can transition predictably between those states using events. Now, I've used state machines in the XState library specifically to model all sorts of flows in development. So for example, UI features or customer onboarding flows or perhaps fintech applications like submitting trade orders and also creative coding projects too. One of the best use cases for state machines is in the development of games. And the reason is that the behavior and the animation of game characters is so suited to states and events and thinking about those. Also, as a bonus, it's very easy to produce a visual diagram from the code, the XState code, and also to export XState code from those diagrams. Okay. So in this game, for example, there are state machines for all kinds of things, like the overall application, the chef and its keyboard input, the hen and her movement, the falling eggs that then turn into chicks and run off. And also for each level of gameplay, scorekeeping, timers, audio controls, lots of things. Okay, don't worry about every single detail, but this is just a bird's eye view of the egg machine, for example. And again, this uses the XState library that we've heard so much about at the conference. Okay, and yes, this is XState code, and I actually have a const named egg state in my code. Now, I realize that wordplay maybe doesn't translate so well to Spanish, so I'm sorry for the bad joke. Okay. Okay. Back to our blue prototypes. We now have separate Canva layers for static background and UI elements and our animated characters. And we have a notion of a timer for each game level. And the state machine tells us whether we're actively playing or whether we're waiting between levels. Okay. Our chef is a bit wider now, making it easier to catch eggs. And we've also replaced the hen with an imported sprite image containing 2 frames, one black and one red. And at the moment that she lays an egg, the hen state machine tells us to crop and position the image sprite so that we either hide the black frame and show the red frame instead. Okay, so at this point, we have many core aspects of the game's movement in place, and interactivity has been tested out. But the game looks like a bunch of moving shapes and a hen who's a temporary stand-in. So it's time to create some graphics for the game. So naturally, I reached for a trusted industry tool, one that we all know for creating vector illustrations. Well, not that one, but that one. This is OpenAI, or DALL-E to be specific. Now, as you can imagine, this is where things got a little unpredictable. Okay, so first order of business was to create my chef. Now, he's energetic, he's persistent, he's a little bit naive, and he loves to cook. So I named him Chef Raffi, after my own son. I uploaded a photo of real Raffi to ChatGPT and asked him to create a chef who would catch eggs from hens above using a pot. I also asked for a sprite with various poses, and so here we have a chef, we've got hens, we have pots with closed lids, so not that helpful, and we have a severed head missing a nose and a mouth. Okay, so this is not exactly what I'm looking for. Okay, next, I got this, which I actually think is really great, but is a bit old for the part, so maybe I'll use that in the future. On the third try, I got this cute chef. He's holding an open pot with steam, which is great for catching eggs, and has a spoon and some tears and other random stuff. I think this might be good for now. Okay, I cropped the sprite, and I imported 2 images of Chef Raffi into the game for now. The alignment isn't perfect, okay, but he has a rectangle where the pot rim is positioned to catch eggs, and I also wanted to try to have the hens lay eggs while moving, not just standing still, and that way the eggs can sometimes drift sideways based on the hen's speed, which should make it even harder to catch. Now, we can no longer use a conva tween for this. We need to reach for conva animation, which gives you greater control over every single frame of the running animation. In each frame, we can calculate positions that go beyond just setting simple duration and target positions. In order to move the chef around, he now has to pick up his feet a bit, but he knows it's worth it because we're now keeping track of how many eggs he's caught in each round. Hard to read on the blue background, sorry. Okay, we went from blue to pink. I don't remember why that is. But Chef Raffi, not the character, but my actual son, he requested that we add colored eggs. And he was like, let's make them worth different points. And in my household, we say, yes, chef. Okay, now next, I went scouting for the perfect hen to play the part. And I had to put out a lot of prompts. I mean, I requested a sprite of hen images to show her from different angles and poses and all this stuff. And trust me, accuracy was a big problem, and so was consistency. It's really hard to iterate on images using like follow-up contextual prompts. Like if you get an image that you mostly like and you try to modify it slightly with another prompt, then the next image just only addresses your last request, and then you lose what you liked about the previous image. You know, I think that ChatGPT's context window can see your previous text prompts, but it really just can't analyze or understand the image it last generated, so it doesn't know what to keep. It's kind of like the game Whack-A-Mole. All right, you have to keep trying until you eventually get what you want. And I thought these looked nice because they have various poses, and they even come with a matching chick, so I cast this hen for the role. Okay, now we have raw images that we need to be able to manipulate them so that we can really turn them into our characters. I used a software called Loguist by a German company called Cinium. And they focus on native Mac apps, so it's Mac only, sorry if that's not for you. But these are very, very high quality apps. And Loguist specializes, of course, in logo creation, but it can really do a whole lot more than that. So you can import raster images and turn them into vector graphics. You can also arrange them into layers, you can edit them. And I was able to here focus on size and alignment to create various states of the hen. Remember the state machine? And they could all be aligned so that when the hen lays an egg while jumping or walking or turned around, then the egg always originates from the same X and Y position. And from there, I exported the images back out to PNG, but you could also export things to JPEG or SVG from this program too. Okay, the next step was to create sprites for these images. So I found an app called Texture Packer, which is specifically designed for sprite creation. It's easy to use the basic features. You just drop your PNGs and configure some sprite settings, and then you can even preview your animations before exporting the sprites. Like here, for example, is our chick. Now sprites, what are they? They're basically exported as a combination of a PNG board and also a JSON file, which has all the metadata you need for cropping and positioning each individual image. So here are all the character sprites. And you could even export one big sprite if you wanted to, with all the characters combined. Now, I should mention that Logoist and Texture Packer, these are both paid apps, but they are relatively inexpensive for the kind of features you get. Combined together, they're around like 60 euros, which are cheaper than Adobe Illustrator. Okay, so finally, I needed a background for the kitchen, and I asked AI for a large, wide kitchen, and I got this instead. I just gave up right there. But in case anyone needs to hear this before the day is out, AI will most definitely not take your job, ever. So instead, I searched for online images of kitchens, and I used Logoist to break them apart into vector graphics, mostly to give them sort of an illustrated style. I like this one a lot, but in the end, I went with this one because of its depth, proportions, and limited color palette. After all, it's a static background. Okay, so until now, we've not paid any attention to fonts. And with everything defaulting to Arial font, the game still kind of looked like a proof of concept, right? Let's face it. Okay, now there's thousands of fonts, and I don't know much about typography, but I knew I wanted a font that looks playful, fairly modern, I guess, and not overly cartoonish. So I finally settled on Arco, which is free to download, and I added the font to my root CSS. Okay, I was pleasantly surprised to see how adding a single custom font in a game really makes the game pop and look like a real game. I mean, it looked much more intentional and, dare I even say, designed. But there was a problem. When the game first loaded, the text was often misaligned. Okay, so at first I thought this was some weird problem with the Canva text component I wasn't that familiar with yet. But then I realized it's just a font loading issue. Now, on websites, there's several terms for all this, all of which basically mean your font's still missing. But in a game where loading assets is pretty much expected, state machines come to the rescue. Now, fortunately, I already had a loading state in my state machine, but now I could finally put it to good use by loading fonts and sprites. I also used a library called Font Face Observer, which monitors the loading of the fonts, and it returns a promise for you. And now everything looks aligned from the start. Okay, with the new font, I was able to put the pieces together, and the updated title for my game is now Egg Drop, What's Up? Because it rhymes and it looks like soup. Yeah, okay, whatever, it doesn't matter. So we can now drop that title screen into the game, and Chef Raffi, as you see, he's grown a little bit bigger. He can also pivot and face different directions that he's moving in. We have a new scoreboard during the gameplay. Okay. Oh, yeah, so you're getting the idea. You can catch things, he can miss catching things, they hatch, they splat, they do all that stuff. And yeah, we even have a new scoreboard like in between the game levels that we saw with the font. But wait, did you hear that? No, I didn't hear anything either, right? There are no sounds in the game, right? And that's a problem. We need to fix that. So the majority of the game's sound effects were recorded by me and my own team. That's me, Raffi, and his big sister Mila. So once we recorded sounds, I brought the audio clips into Audacity, which is a free open source audio editor, to select and trim them. I then used Howler.js to add the sounds to the game. Now, Howler makes it easy to import and control audio files. Here you can see I'm importing a music clip that is set to loop. I'm also adding individual sound effects that each have their own volume. Howler even supports features like audio sprite creation for more precise playback and to use fewer resources too. Okay, so in the state machine, XState has something known as actions, which are for fire and forget side effects. But in this case, those side effects are sound effects. So for example, whenever an egg lands on the floor, we can use an action to play the right sound. We'll hear those soon enough. Okay, I mentioned the idea of introducing a GA into this game, but we need to really talk more about what genetic algorithms are and how they work. The main purposes of a GA are to arrive at a desired behavior, or perhaps an optimal design, or to find a solution to some kind of problem, and also to do it as quickly as possible. So GAs basically use the concept of natural selection, survival of the fittest, as a way to speed up that process of arriving at a solution. How does the genetic algorithm work? Well, there are several steps to the GA. First, there's the population initialization, and that happens only once at the start. Then there's evaluation and fitness. We also have selection, and then crossover, and finally mutation. And we'll see all of those. The last four happen repeatedly, maybe hundreds or thousands of times, and each of those iterations is considered to be a generation, each with its own new population. Okay, the GA is going to manage a sizable population of those individuals we talked about, and the individuals will each contain potential solutions to our problem. Each solution is stored in the individual's DNA. DNA here is kind of like a representation of the individual's characteristics as a solution. It's important also to know that during population initialization, this is where we can first establish a wide range of variation for the population. Now, during evaluation, we let the individuals of the population attempt to solve the problem. This could involve individuals interacting with their environment. The most important part of this stage, however, is the fitness evaluation. Using a fitness function, we can score, reward, or even punish individuals, and each one of them will be assigned a fitness score. Now, only some individuals are going to get selected to become parents of the next generation, and there are various techniques for deciding who to select based on fitness. One of the most common is roulette wheel selection. In this method, the likelihood of being selected is directly proportionate to the individual's fitness score. So, for example, if we were to add up all of the fitness scores together, we would get a pie or wheel, and higher scores would get a larger slice of that. But then when we pick a random position on the wheel, then it's going to land somewhere, giving a greater chance to those with a higher fitness score. However, it's still random, so it's still possible to pick somebody who got a lower fitness score. And that's really good for variety. Now, during crossover, that involves mating parents. Now, we need to maintain the same population size from generation to generation. And for each child, we're going to select chromosomes, genes from either of its two parents. And during mutation, this is where we have a chance to kind of still maintain variety during this step. And we need variation or variety in order to avoid reaching something called local optima. Local optima is basically where the population starts to converge prematurely on what it believes is a solution in the immediate area, but that's not necessarily the global optimum, which is like the best solution overall. And mutation can be calculated according to a mutation rate and a mutation amount. Okay, now that we've created the next generation, we can return to the evaluation step and see how the new population handles the problem. I like to think of the GAs as being a sort of problem-agnostic approach to solutioning. So, I wanted to see if I could add the GA to help automate the evolution of gameplay from level to level. And I defined roughly two goals in using a GA. The first was to ideally make the game more challenging with each passing level. The second was to observe how the game reacts or adjusts in real time to any particular player. In GA terminology, I knew that my hens would be the individuals of the population, so I now call them hendividuals. The first approach was to select some characteristics of each hen that I wanted to vary across the population, like speed, the tween duration, the movement distance, the maximum eggs they could lay, laying eggs of different colors. And in between levels of gameplay, I executed those various stages of the GA: evaluation, fitness, selection, crossover, mutation. Now, since the eggs actually hatched into chicks, it seemed kind of fitting that these chicks would indirectly represent the next generation. So I created a fitness function that evaluated individual performance after each level. It rewarded hens that laid more eggs, and also whose eggs were uncaught. It also added a bonus for hens whose black eggs got caught. And it punished hens that didn't lay any eggs at all. Okay, so the game was now working and running the GA with each level, and I assumed the hens were evolving, but honestly, I wasn't really that sure if the GA was working as expected. I mean, I couldn't really tell whether the game was getting easier or harder. I mean, was it just a matter of time playing it, or was there something about this game that was incompatible with the GA? So I was faced with a real dilemma. I mean, on one hand, I needed to know how to tweak the GA in order to make the game more playable. And on the other hand, I needed to finish building the game in order to play it and test the effectiveness of the GA. It was hard to know which to do first. So I decided to take a break from development and to try to just think through the problem. By the way, this is what I call an American siesta. A GA needs variation and a sizable population so that it can put forth enough potential candidate solutions. But I've only got about 10 hens pacing back and forth up on that beam there. So I realized that the population size was just too small to work with. Believe me, I tried to crank up the population size, but this led to overcrowding and chaos. Oh, chaos, that's helpful. It still performed surprisingly well, though. So I was thinking, like, how can I increase the population without all the hens being visible at the same time? So then I remembered the Kaboom game where bombs were being dropped, and I thought, bombs? I mean, that's it. Each hen could just go on a bombing run. Instead of sharing the stage simultaneously, why not have the population enter from one side, exit off the other side? We can have many more hens at each game level, and they get one chance to drop as many eggs as possible. And I could even double the number of hens by making them go in both directions. So that seemed like an improvement. The population would be larger, but still not hundreds and thousands, right? So I tried to think of other ways that I might be able to tweak the GA to overcome the limited population. For example, adding more genes or hen traits for variety, continuing to tweak the fitness function, or maybe even adding weighted fitness values. I could introduce something called elitism, which is where you still use the roulette wheel selection, but you reserve a certain amount of slots to guarantee that the best performers' genes will always be carried to the next generation. Perhaps there are other methods of crossover, and of course, increasing the mutation rate to a certain point could introduce more variety. I mean, I was willing to try anything, but in order to experiment, I also started separating the code between general GA functions and more game-specific code. For example, this roulette selection function could now easily be swapped out for just some different selection method. Okay, another concept in GAs that's important is the distinction between an individual's genotype and phenotype. Now, for our purposes, the genotype can be basically represented by an array of random values from 0 to 1, each one of them owned by each individual. But the phenotype would be how do these values translate to actual behavior characteristics of the hens in the game. So we can use that array for the genotype values, and the values will be assigned as random values during the population initialization stage at the beginning. But later, during crossover, both parents will bring their own existing DNA to produce offspring. We can then go through the DNA one gene at a time and select either the gene from one parent or the other. And that's going to produce a child who's with the full DNA length that is a mix of its two parents' DNA. But we're still able to keep that genotype separate from the phenotype values. Oops. Sorry. Okay, so for each new generation, we can call a function to calculate a phenotype by multiplying genotype and phenotype values within a range for each individual. And again, we could reuse this whole setup for any other app that uses a GA. So this all started to come together for our individual. On the left, we have our DNA, our phenotype, and our fitness score. And on the right, we extend that and add game-specific attributes for the hen. Let's have a final look at what the game was like to play. Okay, I promise I'll debounce some of those sounds and lower the volume soon. Now this game, of course, is open source. You can check it out, but in particular, if you want to get a deeper look at things like the overall structure of the game, the Canva code and the animations, perhaps you want to look at the state machines, or see the assets, or just follow ongoing development. Now, what kind of experience do we observe after implementing the GA? Well, I collected some statistics at each level of gameplay, and I added like a developer panel so that we can see them over time. Now, there were some good signs of the hen attributes that steadily trended in a particular direction, mostly upwards, over the generations. Things like hen speed, or the egg-laying rates while moving or still, or the distances the hen could move with each animation, or the average time a hen would stop to lay eggs. Now, unfortunately, it wasn't all rosy good news. The total eggs laid seemed to kind of just go up and down, which is weird. The average eggs laid per hen was also kind of strangely bell-curved. However, as a bit of a silver lining, The player's catch rate generally did trend downward over time, even if it wasn't as steady as I hoped. And it seems like the game might get slightly harder despite the increased practice that a player gets with each passing level. Let's hope. So it's important, though, to note that this is like one snapshot from one player over 16 generations. Clearly, there's plenty of more work to do. So in summary, we've covered a lot of stuff here, right? We looked at genetic algorithms and what or how they can be useful. We talked about creating a web game basically from scratch, using React and Canva, state machines and XState, leveraging AI and illustration and sprite tools to create character assets, also a little recording sounds and playing them in your game. And we also saw a way to add a GA to a game that can help to make the game a little bit more dynamic and automated. And we even acknowledged some of the difficulties in applying GAs to games, as well as ideas that could help. In terms of resources, I just really want to tell you about this new book that I got. It clearly is my favorite book right now. It's by Daniel Schiffman. It's called The Nature of Code. And it was just released, and it has everything you need about genetic algorithms and so much more about natural systems and behavior and how to simulate those with JavaScript. I really think that this is the kind of tech book that in 10 years or 20 years will be every bit as relevant and useful by that time. Also, check out things like the coding train. I mean, Daniel Schiffman is just the master teacher. So before I go, I do have some parting words from me and my team.
Go.
Everyone. What's up? Yippee! Oh no. Yes. Yippee! Oh no. Oh no. Haha. 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 What's up? Yes. Haha. Yes.
Over the past couple of months, I've really begun to fall in love with game development. I mean, I think programming is already very creative, but working with games takes that to like a whole nother level. Admittedly, working with the GA in a game felt kind of experimental the whole time. But once you got the basic mechanism underway, then it was amazing to see the game take on a life of its own. If any of you have ever thought about starting to build a game, I highly recommend it. It's super fun. And if you've got your own creative coding projects, or you want to talk about building games, or you just want to go visit the Video Game Museum in Malaga sometime, I really hope you'll come up and say hi to me at the end of the conference. So thank you very much. Muchas gracias. You've been an awesome audience. Yes.